In this presentation, we're going to look at summation calculations used in computing regression coefficients. For example, the intercept estimate and the slope estimate. And these calculations can also be used to compute the correlation coefficient and the coefficient of determination. So these are the notations of the summations we're going to compute. The summation of x, summation of y, the summation of x squared, the summation of y squared, and the summation of the product of x and y. So let's have a look at the data set here. We have our data set x, 10, 15, 20, 25, 30, 35, 40, and we have our data set y, 11, 19, 34, 52, 58, 81, and 109. Now you'll notice the way I've sort of set up the table. This is for a convenient calculation of all the relevant terms. For I also have a x squared column, a y squared column, and an xy column. Also at the bottom I've left room to sum up each column. On the left hand side I have the index. For example, the first, second, third, fourth, fifth, sixth, and seventh case. So, without further ado, what we're going to do is look at a scatter plot of the linear relationship that we are interested in here. Here is the data set x arranged along the bottom and data set y arranged along the vertical axes. And we get this positive linear relationship here. So what we want to do is compute an estimate for this relationship here, for a regression model and also a correlation coefficient. So let's begin. What we're going to do first off is compute the summations of x and summation of y. Now this is a straightforward calculation. What we do here is add up all these numbers in this column here, and so on. So we add up 10, 15, 20, 25, 30, 35, and 40. Add them all up together, we get 175. And in this column here we have 11, 19, 34, 52, 58, 81, 109. Using our calculator we'd find that the sum of those values to be 364. Okay, so what we're going to do now is compute the other columns, values for the other columns. So first off, what I'm going to do is compute x squared. So in the first case, x is 100. X is 10, so x squared is 100. Bit of calculator work. 15 squared is 225. 20 squared is 400. 25 squared is 625. 30 squared is 900. 35 squared is 1225, 1225. And 40 squared is 1600, 1600. And again, what I'm going to do is add up all those values there in the x squared column. And the summation of that column is 5075. So that's x squared. Now what we're going to do is y squared. So the first item of y is 11, and the square of that is 121. 19 squared is 361. 34 squared is 1156. 52 squared we get 2704. 58 squared we get 3364, 3364. 81 squared 6561. And 109 11,881. So we would actually spend quite a lot of time actually computing this in the calculator, but once we have our summations ready later on, the subsequent calculations are quite quick. And again, what we'll do is sum up that column there. So the sum of the y squared column is 26,148. So lastly, what we're going to do is compute the xy column. So in each case, what we're going to do is multiply the value of x by the value of y for that row. So in the first case, we have 10 times 11, which is 110. The second case, we have 15 times 19, which is 285. 20 times 34, 680. 25 times 52, 1300. 30 times 58, 1740. 35 times 81, 2835. And finally, 40 times 109, we get 4360. And once again, we will add up the row, all the items in that column. So 110 squared plus, or 110 plus 285 plus so on and so on. We will get 11,310. So here's the summary of all the calculations that we've computed, all the summations. Now, when we're using subsequent calculations, for example, to compute the mean or compute the slope estimate, the regression estimates, or the intercept estimate, the correlation estimate, we will be able to use these values directly in very simple formulas. So first, before I go, what I'm going to do is show you how to compute the mean of x and y from what we have here. So the summation of x was 175. The sample size is 7. There are 7 items in the data set. So we simply divide 175 by 7. And in this case, it works out something quite elegant, something quite simple, 25. Similarly, for y squared, the mean value of y, we sum up the values of y and divide that by the sample size. The summation of y is 364, divide that by 7, and we get 52. So that is how we would compute all these summation values. I'm just going to move back here a second. So when we are computing our regression estimates, we will be able to use these values directly.